Hello, my name is Uriel. I'm an engineer for Bloomberg Engineering. I work in the ticker plant. It's an organization that deals with about 1 trillion events per day. What my team does is we collect billions and billions of data points from all of our machines, and we compare them daily to try and detect regressions. And all of that prepared me very well for what I'm going to talk about here, but that actually has nothing to do with my work. Because in my spare time, I also like to build shiny stuff that uses C++. So this is my living room wall, and I try to go sometimes bigger. And this is hanging in a friend's living room, which is nice. My biggest project is based off a fairly silly pun. This is a Led Zeppelin, which is a Zeppelin made out of LEDs that has gone to a festival called Burning Man, where it drives around with about carrying 20 people, which is absolutely terrifying, where the person who's done the welding is you and you're a software engineer. One of the more interesting things we have done with it, if the slide will go through, is this thing, which is what is probably the first ever integrated, oh, thank you, live demos. The first ever drone show integrated with an object underneath it, where the lights and the drones are synchronized. And that brings me to today's topic, because how do you synchronize with a drone show? And the answer is you have to read large JSON files. There's a format for drone shows. It's called Viviz. Deep down, and not very deep, it's actually JSON, where what it saves is like it has some metadata. It knows that it has drones because that makes sense. It knows how each one of them moves. It knows how the lights on it changes. In some cases, it has some pyrotechnics on it, so it knows how to read that too, and a bunch of other gunk and things that you care more or less about. And each one of those files can be up to about 1 gigabyte for the larger show. And when you have a Zeppelin that runs off a Raspberry Pi that only has 4 gigs of RAM, that is suddenly an issue because there's not enough of it. So that took me on the journey of how can I start.
Why do you need France on the Raspberry Pi?
That's what the Zeppelin runs on, mostly for weatherproofing. Like you don't want any fans, like the whole solid state thing is really comfortable for that.
Why the entire JSON needs to be loaded to your
We'll get to that. What are we going to discuss today? The first thing that we're going to talk about is DOM parsing versus SAX parsing and introduce those concepts. We'll go into, my library is called Better CPP SAX because it uses SAX parsing. So we'll look what a parser at the end of the day looks like. We'll talk about how was that achieved. We'll do somewhat of a dive into the code and the library. We'll do some benchmarks. We'll have some pros and cons, and we'll compare it there to some of the other libraries that I have looked at the very least. And hopefully we'll have some time for questions. Any questions now? Yes?
Why JSON? If you're working with a lot of embedded distributed devices.
The question is why JSON? And the answer is that this is the standards for the drones industry, which usually has more resources. So DOM versus SAX. Anybody here is not familiar with those terms? Excellent. I will explain. So DOM is probably how you parse most of your JSON or YAML or XML. It means data object models. It means you have some sort of library like JSON for modern C++ or Rapid JSON or SIMD JSON, JSON SIMD. And you read the whole file. You load it into the memory, into some sort of a representation. You have the whole state of the JSON in memory. And you can ask like, hey, the root object, do you have an element named like this? What is it type? Is it a list? Is it a scalar? And you can reason about that with everything in memory. And this is very easy to use, but if you have all of the state, you have memory need that is generally linear to the size of your JSON. And that could be a limitation in some cases. Sax parsing stands for Simple API for XML, which is where the approach came from. It doesn't only apply for XML, and it generally means that you are being fed one token at a time, meaning you're told an object started. There is a key, its value is 5. There is another key, its value is actually a list. The list has an object in it. The object has some fields. The object's end. And this doesn't take a lot of memory. It's also very performance generally. You only have one token at a time. It's very lean. However, it doesn't manage any state. You have to do all of the state management. And that could be painful. Yes, I see a question.
Just because I'm the person you're explaining the differences to. How do you know that the JSON is valid until you parse the entire JSON?
The question was, how do you know that the JSON is valid until you parse all of it? And the answer is, you don't. But you can do, I would say if you really want to, you can do a 2-pass. You can do one very cheap run to validate all of the JSON because validating just the structure is not very hard. And then you can actually parse it. I didn't do it, but you can definitely do it if you want to. All right. So let's look at the end result of what does a parser look like. So here we have essentially the bunch of structs for a drone show. Start at the bottom because it's C++. There's some metadata. There's a vector of drone data. The names are mostly derived from their standard, but which is why it's not always that good. But there's a vector of drones data. Every drone has a vector of its location, which is where it would go. It has a vector of payload actions, which could be either LEDs or pyrotechnics or whatever. And then they all have data that goes further in. It's not super complicated, but it's also not trivial. And this is what a parser looks like. So this is kind of a one-to-one translation. We have them here side by side. Essentially, every type gets a function. There's one extra line at the end of what do you want to do in the case of extra data. But I like it. I wrote it, so I like it. But I hope you like it too. So how do you get there? How do you get from a SAX interface that feeds you one event at a time into this API, which, by the way, if you look, all of the functions are also static, so there is absolutely no state management here. So let's see how that happens. So the first thing that we have to do, there are 3 general levels of abstractions here. One is token parsing, which is taking all of the data from the underlying library and dealing with it. The next one is state management, and once we have all of those, we can start talking about how to build an API that users would actually enjoy using. So token parsing. So I have looked at 3 different libraries for the underlying because I don't really want to parse JSON myself. People have done that before. I just want to get the tokens. So the fastest one is SIMD-JSON, which is extremely fast. Its API is a little bit tedious, but it doesn't really give you a SAX interface, so that kind of went off the table. The second one I went to is the most widely used in the industry, as far as I can see, which is JSON from modern C++, also known as nloman, which has a very easy API. You have an interface that you inherit. It will give you all of the SAX events. It's all lovely. However, it uses std string for all of its strings, which just means that whenever you pass everything around, you have an allocation. And that is painful when you start dealing with billions of data points. And last but not least, there's RapidJSON, which is also very widely used. It's much more performant than nloman. It is still very friendly. It does have a template-based interface, which means that if you get any typos, then it just fails silently and you don't get any errors. But luckily, I have done that for you and then failed miserably, so you don't have to. And it uses CART and size t's for string, which is luckily wrappable by string views these days. So everybody wins. So what does the callback look like? We have a series of functions. And just imagine that you now want to write any parsing logic whatsoever, and you have to deal with those events. There's a few downsides here. The first one is that this is tedious. Let's say that you're expecting a string. You still have to write the other, I don't know, 15 functions Even if they're all error and they all just do the same thing, you still need to have them. That is not great. For every parser that you want to write, you have to create a type that implements all of those functions. That gets big very, very fast. The way that they spell uints, that got me like at least 4 times. The I should be uppercase. And yeah, I don't know. That would be very painful too. If you just need to write like, let's say, 6, 7, 10 of these, it gets big quick. Much bigger than what I wrote at the end, at least. So let's start by creating a different type. Let's start by doing an enum for all of the type of events that we have. Let's look at the values. The bottom line is that there's very few types of values that you can get out of this. Like if you have a string or a key, and honest to God, in the final implementation, we don't even really need the ints. We only have a bool and a string. But these are all of the types that we have. We have monostates for the one that doesn't give any types. And we can create a JSON token, or at least a representation. It has a type, it has a value, and we can now take the fact that we have something that came from the underlying, from the bottom layer, and move it around. And it's cheap. Each one of those is just 32 bytes, not hard to move around. Yeah, I say that here in the next one. So yeah, now that we can take those events and deal with them, how can we start managing state? So my first thought was, oh, I need to manage a state. Let me build a state machine. And that kind of dies quickly when you just think about the fact that when you parse JSON types, you might have recursive types. And once you are trying to insert recursion into a state machine, you start eating dirt fairly quickly. It's much easier to just have a stack. Like when you think about it, JSON is hierarchical. You have like the top level, then you have another level in it or not. And at any given point, you can decide to either have another parser that goes one level in or deal with more events, or just relinquish control back to the level above you that gave you control to begin with. So with that, we can start looking at what does a parser look like. Because whenever you deal with a parser, you have to say like, okay, you got a token in, and what to do next. Well, the options that we have, as you can see here, you can either say, I want to deal with the next token. I'm done. I don't want any more tokens. Give them to someone else. Alternatively, like, oh, I need someone else to take the next token. The replay current is an edge case that we will see it later. And alternatively, something went bad. There's an error. I don't want any more JSON. Just stop whatever we're doing and go home. We can build a result. Like, what does a parser return? It returns the optional error, alternatively, a new parser, and just an instruction on what to do. And with that, we can actually build the parser itself, which is just a stud function that takes in a token and gives you instruction about what you want to do next. Any questions so far? Is this completely confusing, or is this OK so far? All right, I see fingers. That's great. So when you look at it, this is, well, I wouldn't say the most code, but this is probably the most complex code we'll see. This is actually all of the state management for the whole thing. There's a stack of parsers, and then you just get a parse token. You look at the top parser. You feed it a token, and you just either save it's not that complex. Like either you do nothing, you pop the parser, or you add another one. Or you stop the whole thing and blow up and go home. In a couple of hours, we are going home. This is what ingesting the parsers look like from the base interface. It is very, very boring. It just parse tokens. I use way too many designated initializers. You find out about a feature, you abuse it for a year, and then you move on with your life. And with that, we can actually write a parser. So let's look at a very basic example. We have a JSON that has 3 fields. We have a corresponding stack, and we have this absolute mess to the right of what it would look like now. You have to manage with the state of the object. We parse the actual things. Again, very far from the end result. So let's see how we can move next, because we need a much friendlier API. So looking at the first piece of code, like if you'll see, we have at least 12 places where we build parse results. This is, by the way, where I really wished we had Rust's enums, because this is a classic case for this, where you just have a type and it can actually have some payload with it. So we have 12 different parse results that we're building in that thing, which also carries the knowledge of if you use a specific parse result, what is the payload that needs to go with it. We have duplication, because if we parse strings, it looks very, very similar. The only thing that changes there is kind of where to save the result, but you do the same things over and over. And you have a parse result that returns a lambda, where in the lambda, you return another parse result. And if we had this for more complex type with more nesting, this will blow up your IDE very quickly with tabs. So the first thing I've done for this is just wrap all of the parse results. Like, why? No need to see these everywhere. Just automate their creation with just the payload and just saying what you want to do. And this takes us from this to this, which is already a nice improvement. We have removed about 40% of the code just by adding that. I think it's much more readable. I think semantically, where you just say return parser done, it's kind of clear and nice compared, or parse error, or any of the other ones. But let's start talking more about, this is the general one. Let's start about more specific one. When you're looking at JSON, there's only 3 general primitives that you have when you're parsing. You have scalars, you have objects, and you have lists, where a list could internally contain more scalar or more objects or more lists. So there's an object, but it does it within keys, but it's more structured. So let's start discussing an API for scalars. Any questions before I move on? Yes?
Why not maps? Why switches, and switches?
What's the question? What?
Switch cases. Why switch cases? So if this equals this, why not some mapping of the functions? Literal tokens.
The question was why ifs and not maps in my parsers, and I would say that the answer for me is that maps, I mean, you could write that. I think I tried it, and it was just like, it got ugly very quick, and also like it used a lot more memory, because it kind of had to copy them.
Okay, another question, what I have seen in the previous slide, or maybe one before last, is it's pretty the same code for the factory, the new parser, except they're talking itself. Maybe some sense to use it, external memory or something.
We're going to get to this. This is, we're looking for the evolution. Where were we? Scalars. So let's look at what we've done for scalars. And here the question, I think the best one here is actually what is the last bullet point, which is what does the user want to express? When you write the code, what do you actually want to say? And the answer is, I want to parse something into this variable. There's a lot of downside in what we're doing here. It's very clearly there's a lot of duplication. Numbers are kind of a risky deal when you're doing JSON, because let's say that you want to parse a floating point, but the value in the actual JSON is 5. The parser can decide that this is an unsigned integer, like signed and unsigned, floats and not floats. It gets very hairy very quickly. It's actually one of the ugliest parts when I was doing it as before. So let's write a parse scalar function. What do you want to do? You ask the user, what do you want to do next when you get a certain key? And the answer is, I want to parse this. What's the next thing to do? And it's to parse the scalar into a variable. This is very minimal API. And then the question is, how do you move from this into something that can say, I'm expecting a JSON token? So the answer is, you want a new parser because you're waiting for something new that's happening. You look at what is the type. If constructor is lovely. The only types we're actually dealing with is Boolean, because they're a native JSON type. we have for anything that is either an int or a floating point, we just use the std from cars. We're using the fancy new C++ 26 version so that we don't have to check the return value there. And the else there that's hidden is just assigning from a string for anything that can be assigned from a string view. So any questions about this? I don't want to dig into it. It's not that interesting. So let's see. We started with this thing. This wasn't great. We moved to this. And now, once we introduce parse scalar, we are down to this thing. This is nice. This is getting much closer to what we started with. I mean, we're going a long way around. We already had it like 20 minutes ago, but let's do it anyway. So another nice thing about this is very extendable. Like, let's say that you want to parse an RGB type. All you have to do is write an overload for parse scalar, and now you can just write parse scalar and move your own types. So this one just parses it from a string, but it's all done by what the user is expecting rather than what the JSON have. You say, I want to parse a certain type, and the infrastructure takes care of that for you instead of looking at the JSON and understanding what's there. So next up, we have objects. Any questions on scalars while we're here? OK. So let's look at something a little more complicated. We now have a nested type. We have me. Apparently, I'm 5 years old, and I work somewhere where I get paid 5 peanuts. And we want to parse that. So we have the parsers on the right, and this is not that bad. You have, we can look at, do I have a cursor? Yes, we do. You can see that if the key is a job, then we just have to return a new parser that calls parse job, which is another function. And this is nice, but there's still some, oh, wrong way. We still have a lot of duplication here. We do have the same thing that handles the structure of an object in Python, which needs to start and end and have keys. And another downside of this is that we're not actually validating that we have an object. You're saying that you want to have an object, and if an object starts, you just keep parsing. But it would be much nicer if we actually expect that an object starts. And the only piece of code that actually changes or is actually interesting to someone who's trying to do this is where you look at the keys and decide what they are. So why not create that? We can create a new function prototype for parsing objects, which says, I have a key that I just got from an object. I have an object that I'm parsing this into of type T. And this is what I want to express. So, but the question is, like, how do we move from parsing tokens into parsing objects? And this is yet another function called parse object. It is, it's kind of nice. Did I do highlights? I did, yes. So this one actually validates that an object is an object. It uses the immutable lambda. It checks that the first thing that you actually see is a start object token. It goes through the end and just propagates all of the keys into the object parser that we've seen before. So now we can remove even more code. This is now fairly close to what we had before. This is just the keys, a line per every member of the data type, and with the addition of the one parse error, just in case there's some unexpected data. Yes, I see a question.
Is there a specific reason you're returning an error instead of throwing?
The question was, is there a reason I'm returning an error instead of throwing? And the answer there is that if you can throw, it will do the same thing, but you return a parse error, you can actually pass it to the underlying layers and stop the JSON parsing in a more structured way. I also think it's like, I don't know, do you like exceptions in C++? It's a loaded question. It is, yeah, to be expected. Also, I will also say this is not an exceptional case for me. Like saying that you got some invalid data in JSON, that could happen. I don't think this is exceptional to the level of exceptions. But that's my philosophy. So we are now down to the last part, which is list. I think I will try to go through this quickly. How are we doing on time? We have plenty of time. We might end a little early. So what are some of the assumptions we have to do about list? One, because we are doing SAX, we do not know the amount of objects that we have. We all we know is that there is a list and that there is n numbers of objects in it. Those could be scalar objects, other lists, and each item requires its own parser. Think of that, if you have a list of objects, we need to have this first variable for each one of them, just to understand that there is a new object and we need to manage its states. So we can express this. We can say, like, what can we parser this into? It needs to be a container. It needs to have an in-place back, because we need to create a new object whenever we see a new one. And its item has to be default constructible. So, hey, hooray for modern C++, better compiler errors if you don't meet what you're doing. And once we have that, we can start saying that we want to parse a list. So this is, I think, the hardest part here. We have a parse list, and what it takes is a stud function that returns a parser function that takes in the type. So essentially, this means that just a way of saying that we have a list, and then whenever we find a new item, we will just create a new parser for this item and return that to say, like, hey, start handling your tokens and let me know when you're done. Yeah, this is, by the way, when I said that we have the one edge case for the new parser and repeat the last token. It's for lists, because whenever you go into a list, then the next token can either be the next item, or alternatively, the list could be done. So you have to look at it, make your decision, and then return. So thank you, list, for adding the dirt into my library. So yeah, these are not very interesting. These are just a couple of overloads. One is for a list of scalars. Another that just takes the parse scalar as a default. This one is for objects, where you can just parse a list with another object parser. And there's another one for a list of lists, and we do not want to look at that right now. It's tired in the day. We all want to take a nap. This will make all of you just fall asleep right now. So this brings us to this. This is kind of the whole library. The whole thing is about 450 lines. Oh, no, we're not at the end. Let's talk about validating the objects. I'm sorry, there's a little bit more. One of the problems with this, especially taking things on an event-by-event basis, is that when an object is done, you'd never know if you got everything that you expected. Because until it's done, there can always be one more event that will give you the last thing you're expecting. But when it's done, it's just done, and you're not there anymore to do anything. So we need to kind of maybe add a potential point for validating objects. So this is just a small addition to parse object, where you add a validator function that just takes the objects and actually makes sure that it's fine, and at the end, then either returns a parser done or returns an error. But the real reason that this is actually interesting in any way is because another cool thing that doing Sax parsing gives us is it gives us the option to actually parse JSON off a stream. So if you have a very large file, if you're reading JSON from a network, if you want to start doing work before you have the whole file, you can do it this way. Sax is the way to go. You don't need everything. You just do it token by token. And this will allow you to kind of do a lot on the cheap side. It's also an interesting thing about this is that it allows you to kind of say what is the volume of work that you actually care about. You can say, I have a list that is going to be massive, but I want to deal whenever one item in it is done. And you can do that at multiple levels. So once you have the validator, you can just do overloads that don't need storage anymore. You just say, I have an object, I'm parsing into it, and whenever an object is done, I'm just going to give it back to you. And this is, I think, a very powerful tool if you're trying to do large operations off the network, which is slow and boring, just like this talk. So yeah, so this is the whole API. We are way ahead on time. Any questions at this point? Yes?
How do you handle tests and whether you did like low tests for like very big files and like did you measure like performance?
I did. We're going to get to that soon. So let's look at some benchmarks. So the way that it was done is I wrote parsers for SIMD JSON, nloman, rapid JSON, and better CPP SAX. This was tested on Windows because I was using C++ 26 and getting C++ 26 on my Linux box was a nightmare. Core i7, 2.5 gigs. All of the examples were those drone shows. I tested it in two ways. One was reading from a file. One was reading from JSON that was already in memory. Instrumentation was done by overriding new and delete other than rapid JSON, which uses mallocs directly, so that there was a hooking point there to catch those allocations, and averaging 10 runs. So lines of code. So when it goes to lines of code, my parser was 29 lines. nloman was the same. Rapid JSON was one more line, and SIMD JSON was 46 lines of code. All of the code is, by the way, available on GitHub. Memory. So memory was kind of nice. You can see that the blue one is kind of at the low. This is mine. When you go, the x-axis is the size of the JSON in megabytes, and the y-axis is the memory needed in megabytes. So you can see that you get, with SIMD JSON, which is very, very, very fast, but for 360 megabytes of JSON, it needs about 2.5 gigabytes of RAM. I'm using 2.5 kilobytes of RAM. The memory usage is actually, it's linear to the depth of the JSON rather than the length of it. So it's kind of nice. But all of the libraries are all linear. The interesting thing about SIMD JSON is that it actually uses a lot of memory. The left side on the lower graph is when you load it into the DOM. Like, here's a file of JSON, load it into memory, and then the right side is I'm now going to parse data out of that already loaded one. SIMD JSON, for some reason, needs a lot of memory in this stage, which I'm not clear why, but that's their problem, not mine. Runtime. So this is the runtime where parsing JSON from memory. It's not the most performant one when it comes to performance. It's not what I was going for, but it's still doing better than nloman. Again, all linear, more or less. Loading from a file, then I am still better than nloman, and rapid JSON is suddenly approaching close from the bottom. SIMD JSON is still very fast if you have enough memory. And the question is like, why does this take time? It doesn't do that much. And the answer is std function. Trying to use std function for all of this has some dynamic memory allocations, and we are allocating this again, more or less linear to the JSON. The 360 megabyte files has about 550 million allocations, and that just gets painful. I have a prototype of an inline std function that doesn't do any memory allocation. It's just saves everything in place, and if it gets too big, then it just froze. However, I think that writing your own std function is kind of out of scope for a JSON talk. So there will definitely be, maybe there will be another talk, who knows. Maybe there will be more benchmarks that will show up on the GitHub once I have time. But for now, I'm using the original one, and this is where we are. So what are the pros and cons of this? I think that the API that we got to at the end is very, very clean. There's very little overhead, almost no boilerplate. To actually run it as like a single line of parse JSON, here's the parser. Here's a stream, here's the parser, good luck, let me know when you're done. It's extensible. If you want to do more, all of the library is just there. You can always access the lower level of abstraction and do your own thing if you want. I have done some fairly interesting things with that. Very low memory usage, which I think is the highest selling point if you're running. This brings you to, I would say that this memory usage brings you close to embedded world if you're using that little memory. Performance is decent. It's not worse than the worst. It's not the best, but it's definitely usable. It's not too heavy. And the whole library is less than 500 lines of code. Cons is it's not as performant as I would like it to be. I would kind of want it to be the fastest on the market, but who doesn't? The syntax is not always trivial, especially if you're extending it. The fact that every time you're returning something, like the no discards on all of the functions were added. You know, it was a trial by fire. The amount of time we would just forget the return because it just looks like it makes sense, and then everything kind of fails silently was painful. So thank you, no discard. And at the bottom line, it still requires dynamic memory allocation. 2.5 kilobytes allocated and reallocated 500 million times. So yeah, so this is it. All of the code, there's a QR code. All of the code is available there. It's about the benchmarks, the code, the library. And if anybody has any more questions. Yes?
Where are these JSON files being created?
They are being created by the software created by the creatives for the drone show, where they drag things around and set colors and whatnot. I didn't create them. I asked them for my friends who, what he does for a living is drone shows.
And did they create the syncing with your device? They also figured out what was going to be there, or you had to do that?
We haven't done that yet. We're working on it. Now that we have this, we can start working on the syncing. But I can, if you wanna, I can show you later, like rendering 3D renderings of drone shows in my code, which is kind of cool. Any other questions? All right. In that case, thank you. And as always, Bloomberg is hiring.